Hello Sparkers, this is Instant Kafka. This is going to be part 2 of my Maze Generation series. If you haven't watched part 1, you probably want to watch that one first because this is going to just pick up where that one left off. So, actually it's going to pick up after I've done a couple of things. I've added this game settings cube. This is something that I put in most of my levels. I have a video on how to set this up and the reasoning behind why I do this, but this holds all of my game settings and I have them as pinned properties. I moved my cells down, cells across, cell height, cell width over to this. And in the maze generator, I sort of split up the initialize and the initialization and the grid creation onto stage 1, on the stage one page. The initialize, I'm grabbing all these variables from the game settings cube, and this is just so I don't have to reference the game settings cube every time I want to use one of these. So I have my initialize, then I have my stage 1. This is the one that creates the grid. On my main, I call the initialize. I set my current stage to 1, and then I call page stage plus 1, stage 1. So that creates the grid. There's our stage 2 that just displays maze was initialized and how many frames it was initialized. And there it is. Not a whole lot of difference from where we left off, but I just want to let you know about it. Too close. Anybody else have problems moving their camera around with the mouse or the keyboard? Okay. Oh, there's just no in between there. Ah, well, that's good enough. So the next stage is to tell each cell to go find all of its neighbors. The neighbor to the north, the neighbor to the south, the neighbor to the east, and the neighbor to the west. And how do we do that? First thing we need to do is determine what a cell is. And how do we do that? We're just going to set a boolean in here saying is cell equals true. Boolean is cell equals true. And let's make this a little easier to manage later on. Delete this, and indent these. There we go. Okay, now we have a way of determining that this particular object is a cell. How do we find all the cells around it? We just look. I'm basically going to cast array to the north, check for any object that is cell, cast array to the east, south, and west. So here we call this find my neighbors. For each of raycast, we want to do it from this cell's center in a direction north. And we want only objects that are within a certain distance, and that's going to be our cell height. Now, there's nothing on here that says what our cell height is. In the maze generator, because I did add this game settings, I have to make sure that this gets created first. So what I did was I turned my maze generator into a template, and I created it from the game settings queue. Create maze generator. That way I guarantee that this is going to be available with its properties before this is created, where it grabs the properties. Now I need to transfer these properties over to here. To do that, all we have to do is grab the cell width and cell height properties from our creator. Could have done the same thing up here, but later on I might want to set those settings other than the creator on the maze generator. So, but here it's always going to be from the maze generator, so we can just get it from here. Oop, I have creator. Cell width. Oh. Cell width equals creator cell width. Whoever created me, grab their cell width property. Cell height equals cell height. Alright. Now if we go back here, this is going to be the actual value we need. So what do we do when we find one? Well, the next thing we have to do, we're just checking for objects that are closer than cell height to the north. Here we check if it's actually a cell. That's where that is cell comes into play. If it is a cell, we know that there's a cell to the north of us, so we'll set it to that. We'll remember that. Object, new object variable, north cell equals it. Okay, copy this, paste it. We want to go in each of the directions. We have north. Let's make this one east. We'll just go around the compass. Okay, we're going horizontally now in the X direction, so let's change this to width. Closer than cell width. And this is our east cell. This is our south. This is cell height, that's good. South cell. And west. This is also cell width. West cell, great. Objects, no. Values, object. West cell. Okay, so casting the array from the center to the north, only as far as the cell height. If we hit something and it is a cell, then we set the north cell equal to it, and we are remembering it. Now, one very important thing you have to do here when you're using raycast is make sure that these cells are collidable. Otherwise, the raycast won't find them, and you'll be scratching your head like I was for 4 hours trying to figure out why. You didn't see that, I didn't record it. Well, I did, but I deleted it. Alright, so now we have a means of finding all of our neighbors to the north, east, west, and south. Now we just got to figure out how to tell each cell to go find its neighbors. We can do that with another Boolean. Oh, I don't know why I keep doing that. Boolean. Find neighbors. If find neighbors page. Find my neighbors. We only want this to happen once. So after all this is done, let's set find my neighbors equal to false. Oops. Find my neighbors, or find neighbors, equals false. However, we also want to indicate that we have finished finding all of our neighbors. And we don't want to use the same, we want to rely on this because in here, stage 2, we're going to loop through all of our cells and tell it to find its neighbors. At some point, some of them are going to have find neighbors equal to false, and some of them are going to be true. So we can't rely on that. We need to have a separate variable that says, hey, I'm done looking for neighbors. So let's set another one here, call it neighbors found. And this will equal true. Okay, and in here, stage 2, we want to keep this for stage 3, so let's just copy this. Start a new page. Paste it in. Okay, now on here, stage 2, we're going to, for each, all of our cells, hang on, I got a cheat sheet here I gotta look at. Yeah. Find neighbors equals true. I want to do this only when the page is entered, because we're going to do our little loop trick here in a second. I'm going to keep running this code, this page, until all of our neighbors are found. All the neighbors for each cell is found, so we're basically going to do another for each here. Do this. If or when not, it hasn't found its neighbors, skip it. Skip everything. If you remember from the first video, this is a little trick I used to make sure all of these are done doing what I told them to do. And in this case, I told them to find neighbors, and I'm going to loop through until each one of them reports that their neighbors have been found. Then what do we do? Then we switch pages to stage 3. Display maze was initialized. And frame counts. Oh, frame count. We can keep track of our frame count on this at this stage too. Where would we do that? Right here. So we have that in stage 1, I believe. Oh, really? Stage 2. Just paste that in there. This will give us a total frame count for how long all this is taking. So now, I believe we're ready to try it. Okay, you notice the frame count went up to 5 from 3. But how do we verify that it actually found its neighbors? Well, we can take advantage of our good friend display. First, let's make that debug. If game settings debug is true, call this page. Now, if the neighbors have been found, they should show up here. So if we have the north cell, we can display north, east, south, west. East, south, west. Okay. This is a bug that I found out about while working all this out. I don't think this is a problem with the code. I think it's a problem with the engine. It does not like showing all this stuff at one time for some reason. It kind of gives up, it chokes. So on here we have to figure out a different way of doing it. And I had this long, huge nested wins for if there's a north cell, then display it with this. If there's an east cell, but really all we need to do is figure out if all we need to do is count how many neighbors we found. So we go into here. Neighbors found. I'm going to use that. Neighbor count. It doesn't really matter. This is just verification to make sure it's working. Paste. Paste. And paste. Delete all this. Neighbor count. I'm a little happy with the delete key there. Okay. Now as you can see, the corners all say 2 because it found this one and it found this one. The edges say 3. This one, and this one. And for this one, it's this one, and this one. And all the inside ones are surrounded by them, so they all say 4. So we know it's working. Now, if you really need to know, we could do one of these at a time. Display N. All of them except the top row should have an N. That works. If we go in here and check the east cell, all of them but the right side should have an E. Oops. They all have E's except for this side, this edge. All of them but the bottom row should have a south cell. Bottom row is empty. All the rest of them have an S. And all of them but the left edge should have a W. Oh. None on the left edge. So we verified that our neighbor census code is working correctly. Now each of our cells in our grid knows about its neighbors. storing that for later use. Now, why do we need that? Well, because we are going to start carving into these, randomly selecting. We're going to select a cell randomly, and then we're going to select one of its neighbors. And that's how we start carving paths into our grid. And that will be on the next installment, so please stay tuned. Thanks for watching.